Imagine placing Islam inside a computer. You upload the Quran. You upload thousands of manuscripts, historical records, dictionaries, population surveys, scientific papers, and books of commentary. Then you press a button marked Test. A progress bar appears. The machine analyzes every word, every claim, every date, every pattern, and every argument. Finally, one result appears on the screen: Islam true, or perhaps Islam false. Could such a test ever be real? Could data science examine a religion followed across centuries, distinguish revelation from human authorship, measure the preservation of a sacred text, detect every contradiction, evaluate every prophecy, and decide whether faith is rational? Or would the machine reveal something else? Perhaps it would reveal that the greatest mistake was hidden inside the question. Welcome to the Guided Hour, where every journey carries a story and every story carries guidance. Today, we ask whether data science can test Islam. To answer honestly, we must begin with an uncomfortable rule. A test is only as good as the question it was designed to answer. Suppose someone walks into a laboratory carrying a glass of water and asks a scientist, "Is this good?" The scientist cannot begin. Good in what sense? Is it safe to drink? Is it pure? Is it cold? Is it economically valuable? Was it obtained ethically? Will it save someone from thirst? The word good contains several possible questions. Each requires different information. Testing Islam presents the same problem, but on a far greater scale. Islam is not a single number. It is not one chemical compound. It is not one historical sentence. It includes claims about Allah, revelation, human purpose, prophets, moral responsibility, worship, history, scripture, death, resurrection, justice, mercy, and the unseen. Some of these claims concern physical evidence. Some concern historical evidence. Some concern language. Some concern human behavior. Some concern moral reasoning. And some concern realities that no sensor can directly observe. Before a data scientist could test Islam, the data scientist would first have to separate these categories. What exactly is being tested? The existence of an early Quranic manuscript. That is a historical and material question. Whether two manuscript passages contain the same consonantal text. That is a textual comparison question. Whether people who identify as Muslim report a particular behavior. That is a survey question. Whether a prayer was sincere. That is not directly observable in a dataset. Whether revelation came from Allah. That is not a variable a machine can place on a scale. This distinction does not protect Islam from investigation. It protects investigation from confusion. Data science begins with definition. A dataset contains observations. A statistical model describes possible relationships among those observations. A hypothesis states what pattern we might expect under specified conditions. A test compares what was observed with what a model predicted. That process can be extremely powerful. It can detect fraud. It can compare documents. It can estimate disease risk. It can measure uncertainty. It can reveal patterns too large for one human mind to notice. But the method has boundaries. A statistical test cannot answer a question that has never been translated into measurable terms. It cannot detect a variable that was never observed. It cannot repair unreliable evidence by applying more advanced mathematics. It cannot transform a vague statement into a precise conclusion. And it cannot announce the probability that an entire worldview is true simply because a software package produced a small number. The American Statistical Association has warned that a p-value does not tell us the probability that the hypothesis being studied is true. That sentence matters. Many people imagine a p-value as a truth score. A p-value of 0.04 does not mean there is a 96% probability that your belief is correct. It does not mean that chance has been defeated. It does not mean that the conclusion is important. It does not mean that the research design was fair. It does not mean that the data was collected honestly. It does not mean that alternative explanations have disappeared. A p-value asks a narrower question. It tells us something about how compatible the observed data is with a particular statistical model under specified assumptions. Change the assumptions, the model, the measurement, or the sampling process, and the result may change. This is why responsible statisticians report uncertainty. Measurement is not a magical act through which humans obtain perfect knowledge. Measurement is a disciplined attempt to reduce uncertainty while admitting what remains unknown. That admission is not weakness. It is scientific honesty. The Quran repeatedly directs attention toward the responsibilities of knowledge. In Quran chapter 17, verse 36, the believer is warned not to pursue what they have no knowledge of. In Quran chapter 49, verse 6, believers are commanded to verify consequential information before harming people through ignorance. In Quran chapter 53, verse 28, assumption is distinguished from truth. These verses are not textbooks of modern statistics. We should not pretend that they contain hidden equations about confidence intervals or machine learning, but they establish a serious moral atmosphere around evidence. Do not treat assumption as knowledge. Do not spread information carelessly. Do not act before verifying. Do not allow confidence to outrun evidence. That atmosphere should govern an Islamic investigation just as much as any other investigation. A Muslim should not need weak statistics to protect the Quran. A believer should not have to hide uncertainty. Truth does not become stronger when evidence is exaggerated. It becomes harder to recognize. Let us create our first test. The question is not yet, is Islam true? The first question is, can data science determine whether the Quran has been historically preserved? This is a much better question because at least part of it can be operationalized. To operationalize a question means turning it into defined observations. We might ask, what Quran manuscripts survive? Where are they held? What passages do they contain? What material are they written on? How have they been dated? What type of script do they use? How does their consonantal structure compare with later standard texts? What spelling differences appear? What reading marks appear? What corrections appear? What portions are missing? What uncertainty surrounds the dating? What conclusions can the surviving evidence support? Now the question has become a research program. A data scientist could build a manuscript database. Each row might represent one folio or one manuscript witness. The columns might include collection, shelf mark, estimated date, radiocarbon interval, script type, material, passage range, number of lines, visible corrections, spelling forms, verse divisions, and alignment with a reference text. Images could be processed. Transcriptions could be aligned. Differences could be categorized. Researchers could examine whether a variation changes spelling, pronunciation, grammar, or meaning. The code could be published. The inclusion rules could be documented. Other researchers could reproduce the analysis. That would be data science applied responsibly to Quranic history. And this work is not imaginary. Corpus Coranicum, a research project of the Berlin-Brandenburg Academy of Sciences and Humanities, provides systematic access to early Quran manuscripts, manuscript images, transcriptions, and records of variant readings from the Islamic scholarly tradition. Its public description reports tens of thousands of manuscript images from more than 95 collections. This does not mean that one database has solved every historical question. It means that Quranic textual history can be studied through organized evidence rather than slogans. At this moment, an important distinction appears. The Quran states in chapter 15, verse 9, that Allah revealed the reminder and will preserve it. For a Muslim, this is a divine promise. Historical research can examine physical evidence related to transmission. It can compare manuscripts. It can trace orthography. It can study recitation traditions. It can identify stability and variation. But the historical method cannot place "Allah preserved this" into a microscope. It can investigate the preservation. It cannot independently measure the divine agent. That is a boundary, not a defeat. Consider rain. A weather station can record rainfall. It can measure temperature, pressure, humidity, and wind. It can explain atmospheric processes. A believer may understand rain as part of Allah's creation and provision. The instrument measures the physical event. It does not measure the theological meaning of the event. In the same way, manuscript science can examine the history of the text. It cannot turn divine purpose into a numerical column. Now let us approach one of the most famous pieces of material evidence in this discussion, the Birmingham Quran manuscript. It is held by the Cadbury Research Library at the University of Birmingham. The surviving material consists of 2 parchment folios written on both sides. They contain parts of Surah Al-Kahf, Surah Maryam, and Surah Taha, chapters 18, 19, and 20 of the Quran. The handwriting has been identified as an early Hijazi form of Arabic script. A sample of the parchment was tested by the University of Oxford's radiocarbon accelerator unit. The calibrated result placed the parchment between the years 568 and 645 of the Common Era with 95.4% probability. That range is extraordinarily early. But notice the language. The parchment was dated, not the revelation, not the recitation, not the ink itself, not the exact day the words were written. Radiocarbon dating measures organic material. The parchment was made from animal skin. The test estimates when the animal died. The skin could have been prepared and used later. The University of Birmingham explicitly explains that the radiocarbon test does not date the moment when the ink was applied. This limitation matters. An exaggerated presentation might say, "Science proved that these exact pages were written during a particular year." The evidence does not establish that exact claim. A dismissive presentation might say, "The date tells us nothing." That would also be inaccurate. It tells us that the material belongs to a very early period. Paleographic analysis of the handwriting also supports an early date. Together, material dating and script analysis make the manuscript an important witness to the early written Quran. This is what responsible evidence sounds like: specific, strong, limited, transparent. The manuscript was also examined through multispectral imaging. Different wavelengths of light can reveal features that ordinary vision misses. Researchers were looking for hidden writing beneath the visible text. No underlying erased text was detected. The manuscript was not identified as a recycled parchment carrying an earlier erased document beneath the Quranic writing. Again, that result has a defined meaning. It tells us about these folios. It does not tell us about every manuscript. It does not prove the divine origin of the Quran. It does not solve every question about Quranic transmission, but it is a real piece of evidence. If we were building a data science dashboard, the Birmingham manuscript would not be a green light labeled Islam proven. It would be a carefully documented historical observation. Material, parchment. Contents, parts of chapters 18 through 20. Script, early Hijazi. Radiocarbon interval for the parchment, 568 to 645 at the reported confidence level. Hidden underlying writing, not detected. Ink date, not directly established by that radiocarbon test. That is more useful than a dramatic slogan because another researcher can inspect each statement. What happens when the written text itself is compared? This is where the language becomes more technical. Early Arabic writing often lacked the full system of dots and vowel marks familiar to modern readers. Researchers therefore distinguish between layers. There is the consonantal skeleton, often called the rasm. There are orthographic conventions, meaning the ways words are spelled and represented. There are dots that distinguish letters sharing similar shapes. There are vowel marks. There are verse divisions. And there are transmitted readings. Two texts may share the same underlying consonantal structure while differing in spelling conventions, markings, or pronunciation. A careless analyst may treat every visible difference as a different Quran. Another careless analyst may declare that no differences exist at all. Neither approach is acceptable. An honest textual analysis defines the unit of comparison. Are we comparing modern printed spelling, the ancient consonantal skeleton, verse numbering, reading marks? Pronunciation, word order, meaning, every answer measures something different. An academic study of the Birmingham fragments reported no substantive consonantal variants in the examined sections, while identifying variations involving orthography, pointing, and the indication of long vowels. That finding is important, but it must not be inflated. It concerns particular fragments and particular passages. The larger history of Quranic readings is a recognized field of Islamic and academic scholarship. Corpus Quranicum includes a database of early variant readings drawn from historical works. Muslim scholarship itself preserved the science of Qur'at, the transmitted readings of the Quran. Variation is therefore not something that can be handled honestly by pretending no categories exist. The correct task is to identify what varies, what remains stable, what was transmitted, what was accepted, and what effect a particular form has on meaning. Data science can help organize this work. It cannot replace the linguistic and historical knowledge required to interpret it. Imagine comparing two software repositories. One version writes a date as month, day, year. Another writes day, month, year. One uses uppercase letters. Another uses lowercase letters. One file contains punctuation that the other omits. Those are real differences. But they are not automatically differences in the underlying message. Now imagine that one version adds a sentence that does not appear in the other. That is a different category of variation. A responsible comparison system does not place both differences into one undifferentiated count. It classifies them. The same principle matters when examining manuscripts. A headline that says, "Researchers found 100 differences," is nearly meaningless without definitions. Were they spelling differences, marks added by a later hand, damage to the parchment, verse separators, alternative accepted readings, changes in consonants? Missing text, corrections? The number alone does not tell the story. Classification tells the story. Context tells the story. Transparent evidence tells the story. This brings us to a deeper question. Could data science detect contradictions inside the Quran? Quran chapter 4, verse 82 invites people to reflect upon the Quran and states that had it been from other than Allah, they would have found within it many inconsistencies. This verse is often presented as a test. So let us ask what a computational test would require. First, we need a definition of contradiction. In formal logic, a contradiction occurs when a proposition and its negation are asserted in the same relevant sense and under the same conditions. The door is open at noon and the door is closed at midnight are not contradictory. The time changed. The door is open and the door is not open may still not contradict if one statement is literal and the other is metaphorical. Context matters. Definition matters. Reference matters. Time matters. Condition matters. Language matters. An algorithm could retrieve verses containing related terms. It could find passages using apparent opposites. It could map topics. It could identify repeated names, commands, quantities, and descriptions. It could flag pairs of passages for review, but the algorithm would still need to determine whether both passages refer to the same subject, in the same sense, under the same conditions. That is not merely a counting problem, it is a semantic problem. Suppose one passage describes the creation of human beings from dust. Another describes human reproduction through fluid. A simplistic contradiction detector might report source material mismatch, but the passages may refer to different levels of explanation. One concerns the origin of the first human or the elemental origin of the human body. The other concerns the biological reproduction of later human beings. Before declaring contradiction, the analyst must identify the claim being made. This does not mean every proposed contradiction disappears automatically. It means that every proposed contradiction must be stated precisely. Which two propositions conflict? What Arabic terms are involved? What is the context? Are they universal statements or statements about particular circumstances? Does one describe a sequence while the other summarizes it? Does one use figurative language? How did early Arabic speakers and classical commentators understand the passage? Are there alternative interpretations? What observation would allow the contradiction claim to be rejected? These questions do not evade analysis. They make analysis possible. Quran chapter 3, verse 7 also states that some verses are foundationally clear, while others require greater interpretive care. That means a responsible computational project cannot assume that every verse is an isolated database row whose complete meaning appears without context. The Quran is recited as discourse. Its passages address events, questions, objections, laws, stories, warnings, and moral realities. A search engine can retrieve words. It cannot guarantee understanding. A language model can produce an explanation. It cannot guarantee truth. A contradiction audit may use software, but it must remain accountable to language, history, logic, and transparent interpretation. If this episode is helping you see these questions with greater clarity, take a moment to like this episode, subscribe to the Guided Hour, and share it with someone who may benefit. Your support helps more families discover thoughtful and reliable Islamic storytelling. Now let us continue our investigation. The next test is one of the most popular and one of the most dangerous: numerical miracles. You may have seen claims that a particular word appears a particular number of times in the Quran. The number may be connected to days, months, biological facts, astronomical measurements, chemical structures, or historical dates. Sometimes the pattern appears astonishing. Sometimes it spreads through thousands of posts before anyone asks how the words were counted. Data science gives us tools to examine these claims. It also gives us reasons to be cautious. Consider the first decision. What is a word? In Arabic, conjunctions and prepositions may attach to words. Pronouns may appear as suffixes. A root can appear in several grammatical forms. A concept can be expressed through more than one word. A written form may include or omit particular letters depending on orthographic convention. Should all derived forms be counted? Only exact forms, singular and plural. Definite and indefinite. A word with an attached conjunction, a pronoun, a synonym. The answer changes the total. Now consider spelling. Will the researcher count the early Quranic orthography, a modern digital edition, a simplified Arabic text, a text with diacritics? A text without diacritics. Will the researcher normalize different forms of aleph? How will Hamza be handled? Will the basmala at the beginning of chapters be included every time, once, or according to its status in each chapter? Will chapter headings be excluded? What about punctuation inserted by editors? Again, the answer can change the total. Then comes the largest problem. How many patterns were searched before the successful pattern was reported? Suppose a person searches one word and predicts one number in advance. That is one test. Now suppose a person searches thousands of words, roots, spellings, combinations, chapter positions, verse numbers, totals, ratios, multiples, and calendar relationships. Eventually, some pattern will appear impressive by coincidence. This is not an insult to the Quran. It is a mathematical consequence of searching an enormous number of possibilities. If you roll 2 dice once, a matching pair may feel special. If you roll them thousands of times, many matching pairs become expected. The same principle applies to data mining. The more patterns we search, the greater the chance that some will appear remarkable. This is called a multiple comparison problem. When researchers quietly try many analyses and report only the successful result, the practice may be described as data dredging or p-hacking. The American Statistical Association specifically warns that statistical conclusions require transparent reporting and should not depend on crossing one convenient threshold. For a numerical Quran claim to be taken seriously as a statistical argument, the researcher should publish the rules before seeing the result. The text edition should be identified. The tokenization method should be documented. The code should be available. Every inclusion and exclusion decision should be explained. All tested patterns should be reported, not only the successful one. The result should survive reasonable alternative counting methods. Independent researchers should be able to reproduce it. And most importantly, the claim should explain why that pattern was predicted before the search. Without these controls, a numerical coincidence may be interesting. It is not an undeniable proof of revelation. There is another danger. Fragile arguments can harm the very belief they were designed to defend. Imagine telling a young Muslim that Islam is true because a word appears exactly a certain number of times. Later, the student downloads another reliable Quranic text. The count changes because the text uses a different orthographic convention. The student may think the Quran has failed, but the Quran did not fail. The argument failed. It treated a counting decision as revelation. Islam does not require us to build certainty upon hidden filters, selective spellings, or undocumented search rules. The Quran's guidance is not improved by weak mathematics. A beautiful pattern may invite reflection. It should not be called proof unless it survives the standards required of proof. This principle also applies to claims that the Quran predicted a modern scientific discovery through a particular English translation. A responsible investigation begins with Arabic. It studies the word's historical range of meaning. It examines how early commentators understood the passage. It distinguishes a broad description of nature from a precise scientific prediction. It asks whether the interpretation was documented before the modern discovery or constructed afterward. It considers competing translations. It avoids forcing modern technical language into an ancient word simply because one possible English rendering sounds scientific. None of this prevents the believer from seeing signs of Allah in creation. The Quran repeatedly directs human attention toward the heavens, the earth, life, death, rain, growth, and the human self. But reflection upon creation is not the same as claiming that every modern theory was encoded as a secret formula. Faithful interpretation requires restraint. Now let us test another type of claim. Can data science measure what Islam does to individuals and societies? Here the answer is yes, but only in a limited and carefully defined sense. Researchers can survey religious identification. They can ask how frequently people report praying. They can study charitable behavior. They can examine fasting, family structure, education, health, economic activity, social trust, political attitudes, or psychological well-being. They can compare groups. They can track changes across time. They can estimate relationships. But every stage introduces questions. Who was sampled? Who was missed? How was Islam defined? How was religious practice measured? Were respondents willing to answer honestly? Was the survey conducted in a free society or under political pressure? Did the sample include only mosque attendees? Was the survey online? Did it reach people without internet access? Were the questions translated consistently? Were age, income, migration, education, conflict, family structure, and geography considered? A large dataset can still be biased. Size does not repair a broken sampling process. If you ask 1 million people leaving a football stadium which sport they enjoy, the answer does not represent the entire country merely because the sample is large. The selection process matters. Then comes causation. Suppose a study finds that people who report frequent prayer also report greater life satisfaction. What caused what? Prayer may support well-being. People with greater well-being may find it easier to maintain regular worship. Family stability may influence both. Community participation may influence both. Age may influence both. Health may influence both. The direction may differ across individuals. The measure may contain self-reporting error. The relationship may be real while the simple causal story remains incomplete. Correlation is valuable evidence. It is not automatic proof of causation. A responsible researcher may use longitudinal data, natural experiments, matching, instrumental variables, randomized interventions where ethical and possible, sensitivity analysis, and causal diagrams. Even then, the conclusion should match the design. Data science can estimate the effects of a defined exposure on a defined outcome in a defined population under stated assumptions. It cannot honestly conclude, Islam causes success. That sentence is too broad. Which Islamic practice, which understanding? Which population, which outcome, which period, compared with what, under what conditions? The more dramatic the claim, the more definitions it requires. There is also an ethical question. Just because something can be measured does not mean it should be collected. Religious identity is sensitive information. Prayer habits are private. Charitable behavior may reveal financial information. Travel patterns may reveal pilgrimage. Names, languages, locations, and social networks may be used to infer religious identity. A model could classify people who never consented to classification. A government, employer, platform, or security agency could use those predictions unfairly. Quran chapter 49, verse 12, warns believers against excessive suspicion and spying. Again, the verse is not a modern privacy regulation, but it establishes a moral warning that becomes intensely relevant in an age of surveillance. A data scientist may build a model with 90% accuracy and still create injustice. Accuracy is not the only ethical metric. Who experiences the errors? What happens after classification? Was consent obtained? Can the person appeal? Is the model measuring danger or merely learning patterns associated with a minority? Are false positives treated as an inconvenience for the institution and a disaster for the individual? The Quranic command to verify information before harming people confronts the data scientist with responsibility. A prediction is not a fact. A risk score is not a verdict. A correlation is not guilt. A cluster is not an identity. A model output does not remove moral accountability from the person who uses it. Now imagine a different experiment. We train an artificial intelligence system on thousands of texts. Some are labeled divine, some are labeled human. Then we give it the Quran and ask the model to classify the source. Could it detect revelation? No. It could detect patterns associated with the labels humans supplied. It might learn vocabulary, sentence length, rhythm, topic, historical language, genre, scripture-like structure, repetition, theological terms, translation style. It could classify resemblance to the training examples. It could not observe divine authorship. If all texts labeled divine were written in archaic English translations, the model might learn that words such as thee and thou indicate divinity. That would reveal a biased dataset, not a spiritual discovery. Machine learning does not discover the meaning of a label automatically. It discovers patterns that help predict the label. The validity of the result depends upon whether the label represents the concept we claim it represents. This is known as construct validity. If we claim to measure intelligence but only measure vocabulary, the construct is weak. If we claim to measure faith but only measure mosque attendance, the construct is incomplete. If we claim to measure divine revelation but train on human religious classifications, we have not measured revelation. We have measured resemblance to human classifications. This distinction is one of the most important lessons in data science. The model does not know what you meant. It knows what you encoded. If the target variable is wrong, the model may predict the wrong thing with impressive accuracy. This can happen in medicine. It can happen in hiring. It can happen in policing. And it can happen in religious analysis. A polished dashboard does not rescue a confused definition. An advanced neural network does not convert a proxy into reality. A billion parameters do not eliminate the need to ask what the target means. Could an artificial intelligence produce something that sounds like the Quran? It might imitate surface features. It might generate rhymed Arabic. It might reproduce vocabulary found in its training data. It might combine familiar themes. But this experiment would not automatically settle the Quranic challenge. What is the evaluation criterion? Human preference, classical Arabic grammar, rhetorical structure, theological coherence, legal influence, memorability, historical impact, inimitability. Who are the judges? Are they fluent in classical Arabic? Do they know the Quran? Are they informed that the text was generated by a machine? Are they comparing translations or Arabic? Has the generated text copied phrases from the training corpus? Without a defined criterion, the computer produced something similar is not a scientific conclusion. It is an impression. Likewise, the computer failed, therefore the Quran is divine would be an invalid conclusion. Failure may reflect poor training data, a weak model, or a badly designed experiment. Success may reflect imitation rather than equivalence. Data science forces us to define the claim before celebrating the result. We have now reached the edge of measurement. A camera may record a person standing in prayer. A wearable device may estimate movement. A microphone may detect recitation. A calendar may record fasting days. A banking system may record a donation. A location service may record a journey to Makkah. But what did the person intend? Did they pray to be seen? Did they donate from compassion? Did they fast while secretly resenting every moment? Did they make a mistake and sincerely repent? Did they perform a small action known only to Allah? The dataset cannot fully answer. In the first hadith recorded in Sahih al-Bukhari, actions are connected to intentions, and each person receives according to what they intended. This places a profound limit upon external measurement. Two actions can appear identical in the data while differing completely in spiritual meaning. Two donations of the same amount may occupy identical rows, the same timestamp, the same currency, the same recipient, the same transaction type. Yet one may be given for praise, another may be given quietly for Allah. The database records equality. The moral reality is not equal. This does not make data useless. It makes humility necessary. Data is a representation. It is not the whole person. A row in a table is not a soul. A prediction is not destiny. A religious behavior score is not taqwa. A sentiment model is not sincerity. A social network is not brotherhood. An engagement metric is not guidance. A machine may estimate what someone is likely to click. It cannot determine whether the click brought the person closer to truth. This may be the greatest lesson the religious believer can offer the age of algorithms. Not everything valuable is visible to the system. Not everything visible to the system is valuable. So can data science test Islam? The honest answer has several parts. Data science can test specific empirical claims made by Muslims, critics, historians, institutions, and researchers. It can examine manuscript dates. It can compare textual witnesses. It can audit word counts. It can test whether a claimed pattern is reproducible. It can identify cherry-picking. It can analyze historical timelines. It can examine survey results. It can estimate behavioral relationships. It can expose sampling bias. It can detect when a conclusion exceeds the evidence. It can help us ask better questions. It can also challenge weak arguments presented in defense of Islam. That is not an attack upon faith. Removing a weak argument protects the search for truth. Data science cannot directly test whether Allah spoke. It cannot observe the unseen. It cannot place divine wisdom into a target variable. It cannot measure the day of judgment. It cannot calculate whether worship was accepted. It cannot infer complete sincerity from behavior. It cannot turn moral obligation into a correlation coefficient. It cannot establish the truth of an entire worldview through one p-value, one manuscript, one word count, one prediction, or one viral chart. And it cannot disprove a metaphysical claim merely because that claim is not directly measurable. Unmeasurable does not automatically mean false. It means the proposed instrument does not observe it. A ruler cannot measure mercy. A thermometer cannot detect justice. A telescope cannot measure intention. The failure belongs to the instrument's category, not necessarily to the reality being discussed. At the same time, believers must not use this boundary as an escape from every difficult question. When Islam makes or preserves claims connected to history, texts, and human testimony, evidence matters. A false historical claim does not become true because it was shared by a Muslim speaker. A fabricated scientific miracle does not become reliable because it produces excitement. A word count does not become sacred because it appears beneath a Quran verse. A manuscript should not be described more confidently than its dating allows. A critic's argument should not be dismissed before it is understood. A believer's argument should not be accepted before it is verified. Quran chapter 49, verse 6, does not command verification only when information comes from people we dislike. The discipline applies to information we want to believe as well, perhaps especially then. Confirmation bias is strongest when a claim supports our identity, our community, or our hope. The person who loves truth must be willing to investigate favorable evidence with the same care used for unfavorable evidence. The Quran's invitation in chapter 4 is not an invitation to manipulate data until a desired result appears. It is an invitation to reflect. Reflection is deeper than counting. It asks whether the message is coherent. whether its understanding of human weakness remains recognizable, whether its moral commands form a meaningful whole, whether its account of responsibility, mercy, justice, repentance, worship, and death speaks with consistency. Some parts of that reflection involve history and language, some involve reason, some involve lived experience, some involve moral perception, and for the believer, some involve guidance from Allah. A spreadsheet may participate in that investigation. It cannot contain the whole investigation. Imagine returning to the machine from the beginning of our journey. The Quran has been uploaded, the manuscripts have been catalogued, the word counts have been reproduced, the statistical assumptions have been displayed. The uncertain dates have been shown as intervals rather than single points. The social studies have been adjusted for confounding. The algorithms have reported their error rates. The model has listed what it could observe. It has also listed what it could not observe. Now the progress bar reaches 100%, but the screen does not say Islam true, and it does not say Islam false. Instead, it displays a more honest result. Historical claims investigate with historical evidence. Textual claims investigate with manuscripts, transmission records, language, and comparison. Numerical claims reproduce the method and correct for multiple testing. Behavioral claims define the population, outcome, and causal assumptions. Moral claims examine through reason, revelation, conscience, and consequences. Metaphysical claims data science alone is not a sufficient instrument. Intention not directly observed. Divine judgment outside the model. This answer may feel less dramatic than a viral proof, but it is stronger. It does not ask mathematics to pretend to be revelation. It does not ask faith to fear evidence. It does not ask the manuscript to claim more than it contains. It does not ask uncertainty to disappear. It places every question in the domain where it can be examined honestly. And perhaps that is where genuine confidence begins, not with the refusal to question, not with the promise that one equation will remove every doubt, but with the courage to define the question, inspect the evidence, admit the uncertainty, reject exaggeration, and continue seeking what is true. Data science can reveal patterns, it can expose error, it can preserve records, it can compare witnesses, it can protect people from careless claims, but a human being is more than a pattern. Faith is more than a label. The Quran is more than a word frequency table. And truth is greater than the output of any model humans can build. The final question is therefore not only whether data science can test Islam. It is whether we are willing to test our own honesty when we use data in the name of Islam. Will we report the failed tests? Will we disclose the uncertainty? Will we correct a claim that benefits our side? Will we distinguish evidence from interpretation? Will we refuse to call coincidence a miracle? Will we verify before sharing? Will we admit when we do not know? A model can calculate probability. Only a morally responsible person can choose integrity. The manuscript rests beneath the glass. The data points remain on the screen. The confidence interval remains open. And the seeker continues the journey, not with blind certainty and not with empty doubt, but with evidence in one hand, humility in the other, and a heart asking Allah for guidance. You have been listening to The Guided Hour, where every journey carries a story and every story carries guidance. Until our next journey, may Allah increase us in beneficial knowledge and guide us toward what is true.